Everyone, welcome to Sources classes. This is Tushar Shaw, and in today's video, we will be continuing the rest of the part of the racemization process that we were learning. Only two parts are left, that is the cationic formation and bistable intermediate formation. Okay, so the first part which is the cationic bication formation, obviously. Okay, cation formation. I is not dropping out. Okay, so formation. Okay, which is the acid catalyzed process. Catalyzed process. Okay, so let me give you an example here. What is happening? So let us take this plus isomer PH CH CH3. Okay, and if we give SbCl5. Okay, now SbCl5 is a strong Lewis acid. Okay, so it will take up the Cl minus from the system, thus we are creating a positive charge. Okay, so the for pH CH plus and CH3. Okay, uh, this would have, and SbCl6 minus would be present in the solution. Okay, so we know that like any for any reaction, like very famous Petri-Kraft reaction, we know that we require a Lewis like AlCl3, which is a Lewis acid, which could accept the electrons or the minus charge from any compound, so as to form a positive carbocation, obviously. Okay, so in this case also, that is the same thing that which is happening. A carbocation is formed in the presence of a strong Lewis acid. Okay, so now when this SbCl6 would leave the Cl minus, the compound would be again forming, but in this case the plus compound we had taken in the starting, but in this case we will be getting a minus compound Cl, and here it is the CH3. Okay, this one is chiral and this one is chiral. Okay, and obviously plus SbCl5 would be present. So as you can see that using by cation formation by using a Lewis acid, we can racemize the compound, that is from the plus enantiomer to the minus enantiomer. It is formed easily. Okay, so let us take some other examples. Number B. Okay, let's say An CH CH CH3 C2H5. Here An is a group. Okay, plus if we give AlCl3. Okay, now AnCCH3 plus C2H5 plus Al. Here, as you can see, the hydride ion is extracted from this compound. Okay, so now this intermediate would react with this intermediate would react with the original compound itself. Okay, plus AnCH CH3 C2H5. Okay, this would react with the compound itself, producing ANC plus CH3 C2H5 plus minus enantiomer AnCH CH3 C2H5. So what is happening here? Okay, now the intermediate which is formed, that intermediate takes up the hydride ion from another molecule of the single enantiomer that is taken in the starting. Okay, so that like the chain type of reaction. Okay, firstly the chain is initiated by the formation of carbocation, and the hydride ion is taken by the AlCl3, forming AlHCl3 minus. Now this the carbocation thus formed here takes up a hydride ion from the next carbon, next compound. The initial carbocation which was formed thus forms into a racemic mixture. or the racemic modification, and this chain goes on step by step when each molecule takes up the hydrogen ion from the next molecule, forming the racemic modification. Okay. So this is now the Lewis acid that we can use for racemic modification by cation formation are SbCl5, AlCl3, HgCl2, SnCl2, ZnCl2, etc. Okay, these are all Lewis acids, so we can use it in the for the formation of racemic modifications. Okay, so this was about cation through racemic modification formation via cations, and the last one that we'll be studying is under racemization is by formation of stable inactive intermediates. Okay, stable inactive intermediates. So what is a stable intermediate? Let me give an example. Easy for you to understand. pH, CH, sorry, not plus charge. This one is chiral. Why? Has a Cl and a CH3. If we give liquid SO2 or HCOOH, or HCOH is formic acid. So if we give this, what would be formed? A stable intermediate would be formed, which is C6H5 CH double bond CH2. What's happening here is HCl is being removed as a in the intermediate step. Okay, intermediate. Now after this, the HCl will again add itself. Okay, again forming the plus isomer of pH, CH, Cl, CH3. Okay, so from the minus, the plus isomer is formed obviously. So therefore, you can see that racemization is taking place. Okay, another example that we'll be taking is um, minus CH3, CH, OH, CH2, CH3. Okay, we give AlOET here, OET 3. Okay, and acetone, CH3, CO, CH3. Okay, a prochiral ketone will be formed, CH3, CO, CH2, CH3. A prochiral ketone. Okay, prochiral ketone. Why prochiral? Because if we in this carbon, if we remove one hydrogen and substitute it with another any group, so this molecule becomes chiral. Okay, so again after this conversion takes place, plus isomer would be formed, CH3, CH, OH, CH2, CH3. Okay, so this is in this way the plus isomer can be converted into the minus isomer. Okay, so these are the examples that we would study, and the last example for in this topic would be pH, CH, OH, CH3. This one is an active alcohol. Alcohol. Okay, so we give formic acid HCOH. What happens is that pH, CH like OH2 plus is formed with this molecule is obviously chiral. This carbon is the CH3. OH water is removed in this case. Okay, minus H2. The positive cation is formed, carbocation is formed, CH3. Okay, then again HCO minus. What does it do? HCO minus. It may add forming an ether like substituent. Okay, pH, CH, CH3, O, CH double bond O. Okay, so by definition we may say that some products usually like get racemized with the equimolar amount of enantiomers, so they may have different constituents. Okay, like the reagent that we are using, the way may get attached to the carbocation, obviously if the stable intermediate does form. Okay, so in this way racemization takes place. Now the racemization topic is obviously completed. We will be starting the resolution of racemic modification topic in the next videos. So thank you for today this video. We will be seeing you in the next one. Okay.